Hello. In this video, I would like to share information about random variables and probabilities associated with them. A variable is a characteristic that varies or differs from one member of a population to another. A random variable is a quantitative or measurable variable whose value depends on chance. The following variables should be considered random variables because their outcomes can be measured. For example, when a pair of fair dice are rolled, we can measure the results on each, or perhaps their sum. Another example might be the number of blades of grass in each of the yards within your neighborhood. The lifetime of a battery in a flashlight is a random variable when we measure the time it powers the light. And tossing a coin can be considered a random variable if we measure the number of heads or tails. A discrete random variable is a random variable whose possible outcomes or values can be listed. For example, when flipping coins, the possible outcomes are heads or tails. This is a discrete random variable. When rolling dice, the possible outcomes are usually 1 through 6, though other fair dice with different number of faces do exist. The number of blades of grass in your backyard technically can be counted, but it would be difficult to do so. But since the number of blades of grass could potentially be listed, we can call this a discrete random variable. The outcomes of the lifetime of a battery, however, cannot be listed. Instead, we would call this a continuous random variable. When predicting outcomes of discrete random variables, we will often list possible values and corresponding probabilities of each. This is called the theoretical probability distribution. When listing the possible values and the corresponding outcomes or results after a number of trials, we call this the experimental probability distribution. Consider a pair of dice. The possible outcomes of rolling a pair of fair dice would be 2 through 12. We can see this by completing the table on the left, whose rows and columns represents the results of each die. Pause the video now to complete the table by adding the entries from each row and each column to determine the possible outcomes. You should have noticed that the results existed between 2 and 12, and that each sum did not occur the same number of times. The results 2 and 12 only occur one time each out of a possible 36 outcomes, whereas the number 7 occurred 6 times out of 36. By dividing, we can obtain the probability of rolling each of these sums. Take a moment to count the number of possible outcomes and compute the probability of each. Pause the video now and resume playback in a moment to check your work. We now know the theoretical probability of rolling each possible sum of a pair of dice. If we were to roll a large number of times, we would expect to see the sum of 3 approximately 6% of the time, or the sum of 6 approximately 14% of the time. In reality, it is unlikely for our outcomes to precisely match our theoretical probabilities, but they should be close. I challenge you now to find a pair of 6-sided dice and roll them 100 times and track your outcomes. I will do so by using a dice rolling tool online and keep a tally of each outcome. As you can see, the results are not exactly the same as the theoretical probability, but similar. There were more outcomes closer to the middle results, 6, 7, and 8, rather than the extreme results of 2 and 12. In summary, theoretical probability allows us to predict what should happen, and experimental probability shows us what actually does happen after a certain number of trials. The two rarely match, and that's okay. Computing probabilities does not allow us to predict the future, but it does allow us to prepare for it. Finally, I would like for you to compare the theoretical and experimental probabilities of flipping a coin. What is the theoretical probability of flipping a fair coin? What is the experimental probability after 100 tries? Keep track of your results here and consider whether the results from your trials are reasonable. Good luck.